So the first example we're going to do in this video is question number 1 from your homework. So this is the very first problem, and the reason why I want to go over this one is this one's dealing with the difference quotient. So this will give us a good amount of practice with our difference quotient. You'll notice, here's my formula again. Instead of a, they use x, so f of x plus h minus f of x all over h. And then here's my function, this x squared minus x. And we might be tempted to go ahead and start plugging my x in and plugging my h in. The problem with that is this part A. Part A is asking us for us to find the difference quotient as a function. And then we'll plug in the x and plug in the h for each of these different values. So that's what we're going to start with. We're going to start by just finding the difference quotient as a function. So difference quotient is this f of x plus h minus f of x all over h. Well, what does this mean right here? By having x plus h inside of my f function, what does that mean? That means I'm going to plug in x plus h wherever I see an x. So if my function is x squared minus x, everywhere I see an x, I'm going to plug in x plus h. So I get this x plus h all squared minus another x plus h. Right? Everywhere I saw an x, I had to put an x plus h. So that takes care of the first piece. That's f of x plus h right there. And then I'm going to minus my f of x. Well, what's f of x? My f of x is just this whole thing. So let me put another bracket, and I get x squared minus x right here. And that's all still over h. So just to recap, here's my f of x plus h. Here's my f of x. So I still have my f of x plus h minus f of x. Now, you'll notice the instructions do say to simplify your answer. And you're going to see why it's important to simplify, because with the difference quotient, the reason why the difference quotient's a thing is that usually it always simplifies down really nicely. So let's try it out. Let's try simplifying this thing. First off, what's x plus h squared? I'm going to get x squared plus 2xh plus h squared. And if you need to multiply this out by hand, you can do that just by distributing each term, right? This is the whole foiling thing. You get 2xh terms, which is why I have 2 times xh. Anyway, and then over here, I'm just going to have minus x, and then I'm going to distribute this minus term to both terms. Sorry, I don't know what's going on with those weird squares. So I'm going to have minus x and minus h. And then I'm going to do the same thing over here. I'm going to distribute this subtraction term to both of these terms, because that subtraction affects all of f of x. What does that give me? That gives me minus x squared and then a plus x, because I'm minusing a negative x. And that's all over h. Well, if I look closely at what I'm left with, you'll notice that I have an x squared and a minus x squared. What happens to those terms? Those subtract to equal 0. I also have a negative x term and a positive x term. Those also subtract to equal 0. And now I'm left with 2xh plus h squared minus h all over h. Now what do we notice? Now every term in my numerator has an h factor, which means I can factor out an h term, right? I can factor out h from every single one of those terms. So that leaves me with h times 2x plus h minus 1. Do we see that? See how I factored out that h? And then I still have this h in the denominator. Why is it important that I factor out that h? Because now that h cancels out with the h in my denominator. H divided by h will give me just 1. And I'm left with 2x plus h minus 1. So look how nicely that difference quotient simplified for us. Even though it started out looking really, really ugly, it simplified really nice for us. So now I can come back here and say, yep, okay, here's my difference quotient. My difference quotient is 2x plus h minus 1. And now that it's so simple, now that it's simplified like that, that's going to make it a lot easier to plug in these values. So let's try the first couple. So for the first one, my x value is 5, my h value is 2. So that gives me 2 times 5 plus my h value is 2 minus 1. What does that leave me with? Let's see, 10 plus 2 minus 1, that's 11. Okay, and then I can do it again, but just notice I'm keeping the x value the same. All I'm doing is I'm changing the x value, or the h value. I'm changing the h value. So that's going to give me 10. 2.5, 2 times 5 plus 1 minus 1 gives me 10. And then I'll do it again for 0.1. I get plus 0.1 minus 1. That gives me 9.1. Okay, awesome. So the key here is with difference quotients, they should usually always simplify really nicely for you. Okay, let's look at the next exercise. So this is actually question number 2 from your homework. So we're just moving on to the next one, and then this is the last one I'll do. So the rest of them you're on your own. So this is using a graph to estimate average rate of change. Okay, and the kind of the tricky part about this one is you have to figure out what the points are. With all the rest of them, even if it gives you a graph, it'll still kind of give you the coordinate points to help you. But this one, no coordinates are given to you. You've got to figure out the points. And to help you out, just know that that's why they use this word estimate. Don't stress too much about picking the exact right y value. Just do your best, and you'll see that it's kind of, they try to be pretty obvious of what y value to use. Okay, but notice, I want to point out something, right? Notice it gives you intervals. Remember, average rate of change is impossible if they don't actually give you intervals to work with. So it gives me 3 different intervals: 1994 to 2000, 2000 to 2006, and then 1994 to 2006. So 3 different intervals to work with. Okay, well, let's do this first one. So 1994 to 2000. Remember, what do 1994 and 2000 represent? These are my, switch back to regular. These are my x values. When I'm using my rate of change formula, I already know what to subtract in the denominator. I'm going to subtract 2000 minus 1994. Now, the more you get used to average rate of change, the more you can just kind of do that in your head, because what's the bottom represent? It's your change in x values. How many years have passed between 1994 and 2000? Yeah, that's 6. Okay. What goes in the top? Well, the top is, how does your y values change? Well, that requires me to figure out my y values. So let's look at the graph. We're going from 1994, which is actually right here. 1994 is over here, to 2000. So those are my 2 x values that I'm looking at. So now I need to find the corresponding y values. Well, 1994 is pretty straightforward because it's right here at 0. Okay. 2000, I'll come up here and just look for the closest grid line that it's intersecting with. So I'm going to go with that one, and if I follow that one over here, it looks like that's 16. Because 15 is right there. 15 is right under it. So I now have my 2 different y values to subtract. So that gives me 16 is my y value that corresponds to 2000, and 0 is my y value that corresponds to 1994. So that's what I'll subtract. I get 16 over 6, which is equal to, let's see, it says type an integer or decimal, around 2 decimal places, 2.6 repeated. So I'll need to round that to 2 decimal places, and I get 2.67% per year. The next interval, you're going from 2000 to 2006. I already have the y value for 2000. I'm going to use the same exact y value as 16. I just now need a y value for 2006. And once again, don't stress too much about it. Just find the closest grid line that it intersects, and then follow that back. Looks like that's about, yeah, it looks like that's 20. Perfect. So my y value for 2006 is 20. And so I'll set that up in my formula. So my second y value is 20, my first value is 16, and then the corresponding x values are 2006 to 2000, and I get 4 over 6, which is 0.666 repeating. Round that to 2 decimal places, and my answer is 0.67%. Okay, so not too bad, right? It's just reading the graph, making sure that you read the graph correctly, and then using that formula. Okay, I'll let you do the last one on your own, and then let me know if you have any other questions as you keep working through this homework assignment. Have a great day, guys.